Hey, greetings and welcome, mis amigos, mis compadres. Mr. Waddy and my algebra-buddies are here hanging out, talking about transformations, more than meets the eye. And yesterday we were transforming linear equations, so our parent function, you might have said, was f of x equals x, which was like a line with a slope of 1, because there's an invisible 1 in front of that, and a y-intercept of 0, because there was nothing being added to it. But we didn't have that all the time. Like, for instance, in question 18, it says, use the graphs of f and r to describe the transformation from the graph of f to the graph of r. And check this out. So this one's actually a little bit sneaky. This wasn't a translation that went from this white line to the blue line. It looks like it was a shrink, maybe? Actually, whoa, guys, I was looking at it wrong. I was assuming, and there would be some form of a vertical shrink that made this happen, but they actually told us what this was. And because this was a 1/4 on the inside, that means it's a horizontal, all right? And is this a stretch or a smoosh? Yeah, horizontally, this is actually being stretched. Yeah, it's a horizontal stretch by a factor of 4. All right, and the weird thing about the horizontal ones, it's kind of the opposite of what you think. You would think 1/4 of something would make it smaller, but horizontally it stretches it. And instead of by a factor of a 4th, you reciprocate that, you flip it, and it's a factor of 4 times as much. So notice, just to verify, so here, for instance, the x-coordinate of this point was 1, and 1 times 4 is 4, so that's where it would have landed. Question, where would this point have been transformed to? This has a x-coordinate of 2, and so how far over would this be now? Where would that have been? It would have been at 8, right? Because 2 times 4 would have landed at 8. So so you could imagine that this line, right, would have been at 8, -2, right? Would have been another point there. So it is possible to do a stretch like that. So yeah, maybe we'll do some stretches later. Okay, here we go. I think I agree. All right. Let's analyze the original function first. So what is the slope? Yeah, so the slope is 2/3. That means the rise is 2, the run is 3. That means I would go up 2 and then over 3 and up 2 and over 3. So let's see, everyone should be writing this down, right? Unless you got it right, maybe you're solid, right? So the y-intercept is the 1. Let's graph that for firsties, for starters. So y-intercept at 1 and a slope of, watch this, up 2 and over 3 to get another point on that line. And I'll do it again, up 2, over 3, up 2 and over 3. I don't have to, but you're right. I could go down 2 and backwards 3, and that actually would land on a line there as well. Yeah, so here is, actually I'll do it in the blue. How about? Ooh. Nice little sky blue for our spring day that we're having. And I agree with Pooja's analysis. We're multiplying the original function, f of x, by 3. That's on the outside, right? And that means this is going to be a vertical transformation. And for vertical transformations, if this number is bigger than 1, it's a stretch. And that's what, yeah, you were right on the money. And it's by a factor of 3. Okay, so I'm going to take all of these points on this blue line, whatever their y-coordinate is. Why am I choosing y? Because it's a vertical stretch. Whatever their y-coordinate is, I'm going to multiply it by 3. So watch what happens here. So for instance, here is a y-coordinate of 1. What's 1 times 3? 1 times 3 is 3. Here is a y-coordinate of 0, somewhere there. Multiply 0 by 3. That would still actually be at 0. The x-coordinate there is like -1 1/3 or something weird like that. Oh no, actually it's -1.5. But nonetheless. Let's see, where's another one? Here's a y-coordinate of 3. So 3 times 3 is 9. Okay. You guys see how I'm doing this? I'm just taking whatever these points are for their y-coordinate and tripling them. Here's a y-coordinate of 5. Where would this one land? 3 times 5 is 15. That's way off my graph. Let's pick one of these negative ones. Here's a y-coordinate of -1. That's funny. I just said negative ones. It ended up being a -1. -1 times 3 is what? -3. Yes. And let's see. Where's another point? Right over here would have been 1. This was at -3. And -3 times 3 is -9. So triple it. All right. And as we see here, this line is now going to be mucho steeper. It's been tripled in terms of its y-coordinates. It's a vertical stretch, and everything is now 3 times as exaggerated, right? So 3 times higher or 3 times lower in the case of these negative numbers. All right, so that's the way that we kind of perceive these stretches. I was just going to ask you a really cool question. I'm going to do a little side note here just because this is intriguing. If r of x is equal to 3 times f of x, you don't have to write this down. This is just bonus. That means that's the same as 3 times this thing, right? 3 times 2/3 x plus 1. And how could I simplify this? Could distribute. Yeah. And notice the 3 times 2/3, those 3's would cancel out. I'd just get 2x. And the 3 times 1 is what? 3 times 1 is 3. Oh, yeah, okay, all right, I saw it there. So that means r of x, if I did this algebraically, should be 2x plus 3, right? I tripled f of x, right? I tripled this function, f of x, and I get r of x is this. What is the slope of this equation? Yeah, 2 or 2 over 1. Either way is fine. And what's the y-intercept? Yeah, Devin, you agree with that? Is that what your friend's telling you too? Oh, man. All right. False accusation. You got me. I admit when I'm wrong. He was looking at his wallet, not at his cell phone. But maybe, unless... What if you had a friend who like wrote you a note a while ago and you put it in your wallet and you were just finding out now? Like you were doing slow school, old school texting. Or maybe you're friends with George Washington and you're just looking at some ones or some Benjamins, you know, some hundos, you know? Jackson or something? I don't know. So anyways, so guys, look at this. Let's verify our work. Nope. I'm just like making connections for you because chances are the more ways that you can think about this, hopefully the more it makes sense in your mind. So the y-intercept of 3, notice, is what my y-intercept was for my purple line. And a slope of 2, let's see if it actually works. If I go up 2 and over 1, what? And up 2 and over, what? Up 2 and over 1, yes! What? That's crazy good! That means my graphical stretch did in fact verify with my algebraic equation. All right, so whether I multiplied this function by 3 like I did here and then graphed it, I actually ended up with exactly the same thing. But yesterday we were just talking about graphical transformations, so they didn't need you to do that. I was just pointing that out as kind of like a cool side note. That was bonus content. That'll be on like the DVD's bonus content when this video comes out. Extra. So, all right. Here I've got 2 functions. All right. Describe the transformation. It looks like it's being multiplied by 3 on the inside. So what does that tell us? That means it's a horizontal. All right. And it's 3 is bigger than 1, right? 3 is bigger than 1. And that's going to tell me Normally, I would say, oh, that's got to be a stretch. Multiplying by 3? That sounds like it makes things bigger, except for horizontal world, it's opposite day. That's a shrink, horizontal shrink by a factor of 1/3, right? So if I take that 3, if I take that 3, and I flip it, I get 1/3. So let's see if this actually makes sense. So here's a point. I'll pick this point. Its x coordinate was 3. What is 1/3 of 3? What is 3 divided by 3? 1. And notice 1/3 over is right. And over here, if I had -3, 1/3 of that also brought me to -1, right? Right. All right, cool. I think I have one more for us. Ooh, lovely. Now this one's sneaky. This one's tricky sauce. Look out. That's why I'm here to help. All right, let's have, let's see. Who can tell me the slope of the original? Let's see. Yeah, Cameron, do you agree with that one? Yeah, the slope is going to be the 4 for that original function. And what do you guys think the Y-intercept, the Y-intercept is? Yeah, b is equal to 8. Yeah, you guys know how to analyze slope-intercept form. Oh, I like this problem already. Now, all right, so there's the Y-intercept. I move up over 1. Oh, man, I'm off my grid. So watch this. The 4/1, I want to point out, as a fraction is equal to -4 over -1. That means from here I could also go down 4 and backwards 1. And I could do that again. Down 4 and backwards 1. Down 4 and backwards 1. Yeah, I like it. I like it a lot. So here we go. Let's graph this line. So here's our original function. I could pick that point if it kind of seems to line up. Looks like it does. Let's see. Question for you, friends. Here's a bonus question that we haven't thought about in a while. What is the X-intercept of this graph? What is the X-intercept? Thoughts, Ethan? Yeah, and notice I don't know the X-intercept by looking at the equation, right? From the equation I can figure out the slope and the Y-intercept, but X-intercept I can read off the graph and notice he is correct. It crosses at -2. Well done, sir. Well done. Jolly good. Jolly good. So let's do what? This is a crazy transformation. Look at this. What? I'm multiplying by 3/4? Oh dear. All right, so let's see. So this is on the outside. What does that tell me? It's vertical. Vert. Get some mad vert going here, jumping on the court. All right. Vert. And 3/4. Is that bigger than 1 or less than 1? I agree. It's between 0 and 1. That's like 0.75. And for vertical transformations, multiplying by a number between these is going to be a shrink. All right, by a factor of 3/4, or just by 3/4. Now that is going to be tricky. All right, let's see what I can do. Here, its Y-intercept is 4. What is 4 divided by 4? 4 divided by 4 is 1. And then what's that 1 multiplied by 3? 1 times 3 is 3. So I'm going to jump back up here to 3. And notice that if I thought of this as like a loading bar or something for like a video game, this point is like 3/4 of the way towards its original Y value. So I'm gonna get rid of some of my scribbles here just because it's gonna be weird. But this point is 3/4 as high as that one. I'm gonna pick another point that's divisible by 4 because that's gonna be easier. How about this point? So this is at 8. What is 8 divided by 4? 8 divided by 4 is 2. All right. The reason I divided by 4 is because of this. And now let's take that 2 and multiply by 3. And 2 times 3 is 6. All right, so that point is right there. And 6 is 3/4 of 8. or it's 0.75 times 8. It's 75% of 8. Okay? How about this point? This one's 0 for its y coordinate. What is 75% of 0? 0, yeah. Like, that'd be like if your boss that doesn't pay you money was like, I've got bad news. I can only pay you 75% of the 0 that I've been paying you lately. You're like, oh no! And you're like, wait a minute, that's still 0. Okay, that's actually not that bad news. It's just bad news that I've been getting paid 0, right? So yeah, 3/4 of 0 is 0. All right, last one I'm going to analyze here. This one's at -4, right? I'm looking at the Y-intercept. Why am I looking at the Y-intercept instead of the X-intercept? Awesome. Man. Wow. Seriously, you guys got to check out Pooja Math's YouTube channel. She will help you out. I don't know if that exists. But either way, once it does, this is my shout out. This is my recommendation. Yes, I'm choosing the Y coordinate because this is a vertical transformation, right? So here's -4. What is -4 divided by 4? -1. So that would be up here. And then what's -1 multiplied by 3? -3. That would bounce back down to -3. Okay, let's graph this line. Now, 3/4 isn't going to be that much of a shrink. It's right. Notice it doesn't change the line all that much, like so. Let's see. This video is getting so long, but it's so good. It's amazing. I like this. All right. I really wanted to do more. But thanks for watching, internet friends. Have a good day.